So this is a demonstration of the experiment. The first part of the experiment I've shown you is the theoretical calculation for us to get our fundamental frequency. And you've been working with the function generator and the oscilloscope. This function generator puts out, a kind of input into our column, and then we have a microphone that picks up the sound. And one thing that we have to be careful of is that we don't want to go below 250 hertz because it's going to damage the microphone. So what we're going to do is to pick the fundamental frequency for table 1 as our first value for our resonance number 1 in table 2. So the idea is for us to get the resonant frequency for the open tube. As you can see, the tube is open. And when it's time for you to do the close tube, what we're going to do is to just close the tube using that knob over there. So our resonant frequency is going to be the point where we have, the maximum amplitude, and we have, a whole bunch of series of resonant frequency. Your goal is to record this resonant frequency as it corresponds to the resonance number. So I'm going to crank this up until I get to the resonant frequency where you have a maximum amplitude. If this is going out of screen, we also want to note that you might be seeing the wave, looks like it's moving from one point to the other. It's based on the frame rate from the camera, and so that's why just make sure that you just focus on the maximum amplitude. Okay, so as you can see, this is going out of screen. You can reduce the voltage each time, so we get to a maximum amplitude, and that's going to be 341. So our resonance number 2 is 341. Our resonance frequency for resonance number 2 is 341, and we keep cranking it up until we get to the next resonant frequency, which is 518. Next is 696, sorry. 696, as you can see. And we keep going. So right now it's very difficult for me to see what's going on. So you can play with the time base. You can increase the voltage. So I might want to take it back to the last resonant frequency, which is 696. That'll be 877. 1064. 1240. 1438. 1612. And the last one is 1807. So now that we have our values, what we're going to do is to get our frequency difference, which is going to be the difference between any two consecutive frequency, and then we can calculate our harmonic number from the formula on the board from the first part of the experiment, first part of during the lecture where I showed you how to calculate the frequency. So from there you can see how you can calculate your harmonic number. But I'm also going to be providing this data and also attaching it to and sending it to you guys so that you can use these values to write a good lab report. So the same principle also goes for the closed pipe. So we're just going to close the pipe and then we repeat the same procedure. So but it's essentially the same method in which I showed you in the first one, and I'm gonna send the data to you guys and you can work on the data to get a lab report. If you have questions, just let me know by sending me an email.